My name's Keren Callen, and I'm doing, I guess, the very first research paper on polyether ether ketone, or PEEK. Um, let's see here. My paper, or research paper, was on the processability of PEEK, a new polymer for high temperature laser sintering, or HTLS. A list of authors are not in there. So, all right. It came from the European Polymer Journal, and we are going to discuss the processing of PEEK with HTLS and how PEEK should be processed. The experimental data that was used, it was PEEK and PEK. PEK is primarily used in this, the EOS International P800 machine. It is a very high temperature laser sintering machine, and PEEK is the primary powder that's used for it. In this paper, the process conditions that were examined were the build chamber mode. So they have a half, a reduced, and a full chamber. So as you can see here, this is the reduced chamber, this is the half chamber, and this is the full chamber. And the other thing that was being examined in this paper was the post-sintering process, which essentially is just when, after you print a layer of material, there's an infrared heater at the very top of the machine, and it essentially melts the top layer of the printed layer again, so that way you can get rid of any air bubbles or anything that are in there, so that you'll have a more smooth surface to print on top of. The characterization tools that were adopted were the tensile tester and a scanning electron microscope. So the very first thing that was tested was does the build mode affect tensile strength? And so essentially what was happening is that you have a full chamber size, and that is 700 by 380 millimeters in size. All sides of the powder bed are in contact with heaters, and it has the very top of the powder bed exposed to the atmosphere. The half-size chamber is 350 to 380 millimeters, and only three sides are directly heated by the heaters that are within the powder bed, and then the other side is also exposed to the atmosphere, or the atmosphere of the machine itself. And then the reduced size is, or the reduced build mode is 350 to 250 millimeters, and two sides are heated within the powder bed itself, and then the other two sides are exposed. Really what this graph is just showing is that there was not a significant statistical difference on tensile strength by the differences in build mode. The machine that they use specifically for this is like I said, the EOS P800. And that machine is unique in the sense that you can have these three different build modes. And but that was the important takeaway data, is that's what's shown here, is that it didn't have a huge effect on the tensile strength at all. So you could use any of those modes and expect to get the same strength out of it. The second portion of the study is it was testing the post-sintering, and to see if that had a significant effect on mechanical properties as well. The way the post-sintering works is that there's an infrared heater above, and it turns on for 6 to 12, 15 seconds to guarantee uniform melting between regions exposed. And so essentially every time the machine would go over and print something, the infrared light heat source would come on, melt the top layer again to ensure that it was uniform. So they did testing between 6, 9, 12, and 15 seconds on each one of those layers to just see if any of those had a difference in tensile strength. As you can see here in this graph, again, there's not a very significant difference in strength by the post-sintering process between 6 to 15 seconds. Let's see here. Which I actually thought was a little interesting. I mean, I don't know. I guess I don't know. I just thought that the more you melted the top layer, the better your mechanical properties would be. And as you can see here, it really peaks at the 9-second mark. So I thought by using a 15-second one that it would have the highest, and it actually didn't. So that kind of shocked me. But in summary, the key conclusions from the paper, The build modes do not significantly affect tensile strength. Um, After following an optimization process for the peak components, it achieved a 20 megapascal lower tensile strength value than the current commercial PEK that is used. The paper made it seem as if that was not a huge discrepancy, but I guess within the confines of what the material will be used for, it isn't to them. So I thought that was pretty interesting too. But and also the post-sintering operation does not seem to be sensitive to exposure time of the infrared light at the very top. More personal critique, usefulness of the paper. I thought it was very informative, and it tells the reader how peak should be processed and used within this machine itself. What I was not a huge fan of on this paper is that it was 24 pages long, which I'm not worried about that, but they would be discussions later on in the paper that would revert back to figures that were shown. So you'd be on page 12 of this paper, and then all of a sudden it would say, well, look at figure 1. And I'm like, well, we're all the way down here now. So I thought that was a little odd, but all in all, I thought it was a very